In 1980, America's Pacific Northwest experienced a different and rare type of eruption that acted like a giant cannon blast, flattening entire forests and killing dozens. The Cascades are an 1,100-kilometer-long majestic range stretching from Canada to Northern California. Hundreds of thousands of hikers and skiers find refuge and adventure here. But in the spring of 1980, one of the Cascades' crown jewels begins to fracture. In March, small earthquakes ripple deep below the peak of Mount St. Helens. After more than 120 years of slumber, the mountain is awakening.
This seismicity is typical of volcanoes when they reawaken, because as molten rock tries to push its way up underneath the volcano, it makes a lot of noise in terms of shouldering aside the hard rock that makes the edifice of the volcano itself.
On May 17, Keith Ronholm, a geophysics graduate student intrigued by the mountain's activity, decides to get a closer look.
Mount St. Helens was erupting about every 5 or 8 days. I had gone to a place called Bear Meadow to try to get a view of one of these small summit eruptions.
Ronholm gets far more than he bargained for. At 8:32 on the morning of May 18, a magnitude 5.1 earthquake rips through the volcano's north side. 2.8 billion cubic meters of earth falls at speeds of up to 257 kilometers an hour.
I was reading a book in my truck when I heard some people yelling, and I looked over at the mountain, and the entire north side of the mountain was sliding down.
The Earth's movement releases the enormous pressure holding the magma inside the volcano. A 24-megaton blast, over 1,800 times more powerful than the Hiroshima atomic bomb, shatters the north face of the mountain. The blast is unusual in that it doesn't shoot straight up as most eruptions do. This is a rare lateral blast, slamming a huge cloud of rocks, trees, and ash approximately 180 degrees out from the mountain.
There was a puff of dark gray churning ash, and within 10-15 seconds, that ash had expanded out and had covered the entire mountain. All of this was happening silently, and it was no noise to reinforce my flight response. I was 10 miles away, and you don't, at least initially, feel like something's going to hurt you from 10 miles away. So I stood there and I took pictures, and I was fascinated by watching this event.
As the huge cloud of debris races over the two ridges between the volcano and Ronholm at 483 kilometers an hour, Keith suddenly realizes he's in serious danger.
As I'm driving out, I took one last picture over my shoulder, and it's a little motion blurred, but I couldn't take time to frame it or stop because I was driving. And I remember looking back at the little parking area, realizing that I was the last person to leave and thinking maybe I'd waited a little bit too long because this cloud was rushing towards me.
Luckily for Ronholm, the strongest part of the blast heads north and northwest. The portion that's heading northeast, directly towards him, has less energy, allowing him to escape down the mountain. The lateral blast spews ash and gas up to a height of 24 kilometers. Less than an hour later, a vertical eruption sends more ash skyward. Into this grim scene flies Jess Hageman with the Washington Army National Guard.
Most of the trees were blown over by the eruption, and we're talking about 14, 15 miles downstream of Mount St. Helens. The whole landscape was changed. It made you feel like sort of a gnat flying around the universe, because in comparison to the size of the eruption, it was amazing.
Amazing and horrific. 800-degree pyroclastic flows race down the steep flanks at up to 129 kilometers an hour. In some places, they are 37 meters thick. In the early hours of the disaster, the enormity of the destruction to the landscape is impossible to comprehend. But it only takes one sobering moment for Jess Hageman to realize the human toll.
It was on this ridge right straight ahead of us here that we found the first two survivors in the blast area. And that turned out to be Jim Skamanki and his partner, Leonti Skirkadov. And we eventually were able to pick those two people up. Leonti died in the hospital after we got him there, but Jim is still alive and survived.
Rescuers find a handful of stunned survivors, but the eruption kills 57, mostly campers and tourists. 9 hours after its start, the eruption ends. Scientists struggle to comprehend the enormous scope of the event. Before the eruption, Mount St. Helens stood at 2,949 meters tall. Now, it's 401 meters shorter. The blast destroyed enough trees to build 300,000 houses. Thousands of logs still litter Spirit Lake, 5 kilometers from the summit. The volcano shot out more than 508 million tons of ash that spread across the entire US in 3 days. 2 days after the eruption, geologists get their first close look at the desolation.
It was like walking on the moon. I have never seen anything like it. This entire area, which is 600 square kilometers or 230 square miles, was totally devastated. There wasn't a living thing in that entire area, not an insect or a bird or an animal. There was only one color, and it was this gray color of the deposits. The ground was covered with hot rocks, and there were fumes and hot gases coming out of the ground all over the place.
In the months following the eruption, teams of experts carefully study every facet of the mountain. One oddity of Mount St. Helens was that some people heard the eruption as far away as Canada, but eyewitnesses like Keith Ronholm, just 16 kilometers away, heard nothing.
Because of the way the temperature structure in the atmosphere gets cooler with height, that the sound waves from explosions are bent away from the surface of the Earth. And when they reach the stratosphere and the temperature again increases with height, they're bent back down. So no one between 6 and 60 miles from Mount St. Helens heard the May 18th eruption.
Since 1980, the mountain has experienced tens of thousands of small earthquakes and numerous minor eruptions. Most significantly, since 2004, the volcano has been continuously erupting lava, creating a giant lava dome that is still growing today. It's volcanologists like Rick Lahusen's job to find ways to monitor all of this activity.
What we needed was a way to get our instruments out there very quickly without putting people on the ground in harm's way, and yet still be able to monitor changes in the eruption. So what we came up with is this stainless steel superstructure, which kind of looks like a daddy long-legged spider, so we kind of call them spiders. This is a GPS antenna which receives timing signals from satellites and lets us locate exactly where this is. The signals go into the computer system, and then the data come out at the request from computers back in the office and are transmitted out through this antenna.
With the spider securely attached to a chopper, it's time to head into the belly of the beast. As they approach the crater, the new lava dome is visible, spewing out sulfur dioxide gas and steam. This is proof that magma is reaching the surface with the potential to build to another eruption. The most dangerous moment for Rick and his pilot comes as they place the spider on the lava dome. This close to the crater floor, exploding rocks or a sudden burst of steam could easily kill them. Operating with the precision of surgeons, the men carefully place the spider directly on top of the lava dome. Within seconds, the device begins gathering and transmitting data. At At the Cascades Volcano Observatory in Vancouver, Washington, Lahusen analyzes the spider's digital camera images. Time-lapse photography shows the lava dome's formidable growth.
What's really phenomenal about this is how much rock is coming out of the ground. It's taller than the Empire State Building. It's coming up at 5 meters per day, more than 200 meters across, and it's right here in our backyard.
No conclusions have been drawn yet about the lava dome's rapid growth. Geologists warn that an eruption similar to the 1980 event is possible, but unlikely. They are certain, however, that future eruptions of some sort will occur. Whatever its future, the mountain's recent past continues to reverberate today, especially for those who were there.
It's just an amazing event to witness. That we normally think of the Earth as being a very static, stable environment that doesn't change. But when you get to watch a volcanic eruption and you watch a giant piece of the Earth slide away, followed by this dynamic churning ash cloud that flattens tens of square miles of forest, you realize how powerful nature can be and how powerful geologic forces can be.
Mount St. Helens VEI-5 lateral blast destroyed a massive amount of land and killed 57 people.